Ever wondered how data scientists make predictions about uncertain events? They might be using something called a Monte Carlo simulation. This isn't a high-stakes poker game, but a mathematical technique named after the famed Monte Carlo Casino in Monaco. Just like casino games, the simulations deal with uncertainty, chance, and outcomes. At its core, a Monte Carlo simulation is a computational algorithm that relies on repeated random sampling to obtain numerical results. Think of it as a digital crystal ball running thousands or even millions of trials to predict the outcome of an uncertain event. It's like rolling a dice a million times to understand the likelihood of each outcome. The beauty of Monte Carlo simulations lies in their ability to unpack complex systems and processes. They help us navigate through the fog of uncertainty, allowing us to make informed predictions about the future. So, Monte Carlo simulations are all about understanding uncertainty and making informed predictions. Now that we know what Monte Carlo simulations are, a question arises. How do they work? Well, Monte Carlo simulations are all about uncertainty and randomness. They work by defining a set of possible outcomes, assigning probabilities to these outcomes, and then running the simulation multiple times. Let's unpack this a bit. First, it all starts with defining the possible outcomes. For instance, if you're trying to predict the outcome of a dice roll, the possible outcomes are 1, 2, 3, 4, 5, or 6. In a business context, the outcomes might be potential future prices, profit margins, or demand levels. Next, we assign probabilities to these outcomes. This is where it gets a bit tricky, as these probabilities might be based on historical data, expert opinion, or other sources. Back to the dice example, the probability of rolling any given number is 1 in 6, as there are 6 possible outcomes. In a business context, these probabilities might be based on historical market trends or economic forecasts. Once we have our outcomes and probabilities, we run the simulation. But not just once or twice, we run it thousands or even millions of times. Each run of the simulation is called an iteration. The more iterations, the more accurate the predictions. Why so many iterations, you might wonder? Well, the beauty of Monte Carlo simulations lies in their ability to capture the complexity and uncertainty of the real world. By running the simulation multiple times, we can see all the different ways that events could unfold. Lastly, we analyze the results. Each iteration gives us a possible outcome. Collectively, these outcomes provide a range of possibilities and their associated probabilities. This range can help decision makers understand the risk and uncertainty associated with different choices. So, in essence, Monte Carlo simulations use randomness and probability to explore a world of possibilities. They allow us to peer into the future, not with a crystal ball, but with a mathematical model that embraces the complexity and unpredictability of the real world. Monte Carlo simulations, hence, provide a detailed view of what could happen in the future based on probability. I'm being informed. Let's consolidate what we've learned about Monte Carlo simulations. This powerful tool helps us predict the outcome of uncertain events. It does this by running a multitude of trials, each one a what-if scenario, and using probability to predict outcomes. The more scenarios we run, the more accurate our predictions become. Think of it like tossing a coin. The more times you toss, the closer you'll get to the true probability of landing on heads or tails. It's the same with Monte Carlo simulations. The more iterations we run, the more we refine our vision of the future. But remember, it's not about predicting with absolute certainty. It's about understanding the range of possible outcomes and their likelihood. This gives us the power to plan better, make informed decisions, and navigate the future with confidence. Remember, the magic of Monte Carlo simulations lies in their ability to turn uncertainty into a much clearer picture of the future. As always, the power of prediction lies in the numbers.